Hi everyone, my name is Jake, and today we're going to be talking about designing accessible software. Specifically, we'll cover what accessibility means in the context of technology, why it matters, what the relevant standards are, and what you can actually do as a developer to make your software more accessible. Accessibility is a topic that often gets treated as an afterthought during development, and one of the goals of this video is to push back on that and make the case that it needs to be part of your process from the very beginning. So, let's begin. What do we actually mean when we talk about accessibility? At its core, accessibility is about ensuring that resources, whether that's a building, a document, a service, or a piece of software, are equally available to people who have disabilities or face other barriers to use. When we talk about barriers, we're talking about anything that prevents a person from being able to fully use or access something. In the physical space, a curb without a ramp is a barrier for someone using a wheelchair. In the digital world, an image with no description is a barrier for someone using a screen reader. The concept is the same in both cases. We are asking, who might be excluded from using this, and what can we do about it? It's also worth noting that accessibility is not just about permanent disabilities. Someone might have a permanent disability, a temporary injury that changes how they interact with technology, or be in an environment that limits how they use a device, like a loud room where audio is not an option. Accessibility accommodates all of these situations. Now, let's narrow that down to software and digital content specifically. When we talk about accessible software, we mean software that has been designed and built in a way that ensures that all users, regardless of disability or barrier, can access and use it effectively. The key phrase there is designed and built. Accessibility is not something you bolt on at the end of a project. It needs to be considered during requirement gathering, during design, during development, and during testing. We'll come back to this idea near the end of the video. Some common examples of accessible features in software that you may have already encountered include alternative text on images, which is a short description that a screen reader can read aloud for a user that's blind or has low vision, keyboard navigation, which allows a user to move through an entire interface using only the tab key without ever touching a mouse, and captions on video content, which display spoken audio as text on screen. These might sound like niche features, but subtitles alone are used by millions of people without hearing difficulty every day. That's something that we'll come back to shortly. At this point, you might be thinking, how many users does this actually affect? And the honest answer is, more than you would think, and also that framing misses the bigger picture. According to the World Health Organization, over 1 billion people worldwide live with some form of disability. That's a significant portion of any potential user base. But beyond the number, there's a concept sometimes called the curb cut effect, which refers to the way that features designed for people with disabilities often end up benefiting everyone. The name comes from curb cuts in sidewalks, which were designed for wheelchair users but are used constantly by people with strollers, delivery carts, cyclists, and so on. Subtitles are a perfect example of this in the digital world. Subtitles exist as an accessibility feature so that users who are deaf or hard of hearing can follow along with video content, but they're incredibly widely used by people without any hearing difficulty at all. If you've ever watched a video on your phone with the sound off, or on a bus, in a waiting room, or relied on the subtitles to follow what was happening, you've benefited from an accessibility feature. TikTok auto captions are a great real-world example of this exact thing. Beyond the ethical case, there's also a legal and an organizational one. In Canada, the Accessible Canada Act creates enforceable accessibility obligations for federally regulated organizations, and complaints about inaccessible digital products can be filed with the Accessibility Commissioner. Beyond federal law, organizations that fail to meet accessibility standards face real reputational risk and potential liability. For a product you're building professionally, inaccessibility is not just a UX problem, it's a business and a legal exposure. So accessibility is not just an ethical obligation, it makes your software better for everyone, and it protects an organization that builds and uses it. Before we go any further, I want to be transparent about something. Incorporating accessibility into your software does add cost. It takes additional time to learn the standards, to implement things correctly, to test with assistive technology, and to involve users with accessibility needs in your process. That's real, and it wouldn't be fair to talk about why you should care about accessibility without acknowledging it. That said, there's several things worth keeping in mind that put cost in perspective. The first is timing. Building accessibility in from the beginning of a project costs significantly less than trying to add it at the end. If you've already built an interface without considering keyboard navigation, going back and retrofitting it's expensive and often messy. If you consider it during the design and development, the decisions that produce an accessible interface are often not much work than the decisions that would have produced an inaccessible one. We mentioned this in the previous slide, and it's worth repeating here. The cost argument is actually one of the strongest reasons to treat accessibility as a design requirement from day one rather than a post-launch checklist item. The second is reach. Accessibility widens your potential user base. The over 1 billion people worldwide living with disabilities represent real users your product could serve. Inaccessible software excludes them entirely. From a product perspective, the cost of making something accessible can often be recouped simply by not locking out a significant portion of your potential audience. The third is that it gets easier. The first time you think carefully about keyboard navigation or color contrast or screen reader compatibility, it takes real effort. The second time, less so. Developers who work with accessibility regularly describe it becoming part of how they think about interfaces from the start, rather than a separate concern they address afterwards. The upfront learning investment pays forward in every future project you work on. Fourth, learning to design with accessibility in mind tends to reveal barriers you didn't even know existed. When you work through how a screen reader user experiences your interface or how someone with limited motor control navigates a form, it changes how you think about the interface design more broadly. Most developers who go through that process find it genuinely shifts their perspective. Finally, co-designing with users who have accessibility needs, which we'll talk about more near the end of the video, can actually make the process easier rather than harder. People with lived experience using assistive technology can quickly identify the most significant barriers, which helps you focus your effort where it matters most, rather than trying to anticipate every possible issue from the outside. Before we get into standards, let's take a moment to talk about assistive technology, because the standards we're going to cover are largely written around ensuring that software works correctly with it. Assistive technology, often abbreviated as AT, refers to any hardware or software used by people with disabilities to help them interact with technology or the world around them. Some common examples include screen readers, which are a software application that reads the content of a screen aloud. Screen readers are used by people who are blind or have low vision, and they work by interpreting the structure of and content of an interface and converting it to synthesized speech or braille output. NVDA and JAWS are popular screen readers on Windows, and VoiceOver is built into Apple devices. Braille displays are another assistive technology. They're physical devices that connect to a computer and translate text on screen into braille that a user can feel with their fingertips. A third common assistive technology are switch devices, which are input devices used by people who have limited motor control and can't use a standard keyboard or mouse. They might be a single button switch, a sip and puff device controlled by breath, or eye tracking software. These typically work by cycling through options on screen and selecting when the right one is highlighted. The reason this matters for developers is that your software needs to be built in a way that assistive technology can interpret and interact with. If your interface can't be parsed by a screen reader or can't be navigated without a mouse, users who depend on assistive technology are effectively locked out. The standards we're going to discuss exist to prevent exactly that. Now, let's talk about the standards that define what accessible software looks like in practice. There are two main ones that you need to know about. The first is the Web Content Accessibility Guidelines, or WCAG. This is the primary international standard for accessible web development. It's developed and maintained by the World Wide Web Consortium, also known as the W3C, through their Web Accessibility Initiative. WCAG is what most developers are referring to when they talk about web accessibility standards. The second is EN 301549 version 3, which is a European standard that takes a broader view. It covers accessibility requirements for software beyond just the web, including native applications, operating systems, and hardware. Importantly, version 2.1 of WCAG is incorporated into EN 301549v3, so the two standards are closely linked. In a Canadian context, Accessibility Canada has legislated the use of EN 301549v3 as the federal standard for accessibility through the Accessible Canada Act. This means federally regulated organizations in Canada are expected to meet these requirements. So even if you're not building something for the European market, this standard is directly relevant to work done here in Canada. We're going to spend most of our time looking at WCAG in detail, since it covers the most directly applicable standards for web developers, and then we'll cover what EN 301549v3 adds on top of that. WCAG is organized around 4 core principles. You can remember them using the acronym POUR for perceivable, operable, understandable, and robust. Every success criterion in WCAG maps back to one of these 4 principles. Before we go through each one, I want to flag a useful resource. The W3C maintains a quick reference guide for WCAG 2.1, and the link for that is on the resource page. If you're working on a web project and want to check your work against the standard, that's the place to go. You can filter by principle, guideline, and conformance level. Now, let's go through each principle one by one. The first principle is perceivable. This means that all information and interface components must be presented in a way that users can actually perceive. In other words, they need to be able to process it through at least one of their senses. If someone can't see an image, they need another way to access that information. If someone can't hear audio, they also need an alternative. Perceivability is about ensuring that no information is locked behind a single sensory channel. WCAG breaks perceivability down into 4 areas. The first is text alternatives. Any non-text content, including images, icons, buttons that use pictures instead of words, all need to have a text alternative. The most common example is alt text on an image tag in HTML. A screen reader will read that alt text aloud to a user who can't see the image. If your image is purely decorative, you can use an empty alt attribute to tell the screen reader to skip it. But if the image conveys information, like if it's a chart, a diagram, or a photograph with meaningful content, that information needs to be described in text. The second area is time-based media. Videos and audio content need alternatives. For video, this means captions, text that appears on screen synchronized with the spoken audio so users who are deaf or hard of hearing can follow along. It also means audio description for video content where visual information is important and not captured in the dialogue, so that users who are blind or have low vision can understand what's happening on screen. The third area is adaptable content. Content should be structured so it can be presented in different ways without losing meaning. In practice, this means using proper HTML semantics. If something's a heading, mark it with a heading element, or if something's a list, use a list element. Don't just make text look like a heading by making it large and bold. Use the actual heading tag. Assistive technologies rely on this semantic structure to present content in alternative ways, like reading out a document outline or navigating between sections. The fourth area is distinguishable. Content needs to be easy to see and hear. This covers things like color contrast, where the text on your page needs sufficient contrast against its background for users with low vision or color vision deficiencies to read it. It also means you shouldn't rely on color alone to convey information. If you're showing an error message in red, include an icon or text label as well, because not all users will be able to perceive the color. Additionally, text should be resizable without breaking the layout of the page. The second principle is operable. This means users must be able to interact with and navigate your interface. Critically, this includes users who aren't using a mouse. Many people who use assistive technology navigate entirely by keyboard or use switch devices that emulate keyboard input. If your interface requires a mouse to use, you've locked those users out. WCAG breaks operability into 5 areas. The first area is keyboard accessibility. Everything that can be done with a mouse must also be doable with a keyboard alone. Clicking buttons, filling out forms, opening and closing menus and dialogues, all of it. This includes ensuring keyboard focus is always visible, so users navigating by keyboard can see where they are on a page at any given time. The second is giving users enough time. If your content or interface has a time limit, like a session timeout or an auto-advancing carousel, users must be given enough time to read and interact with it, or to be able to pause, stop, or extend it. Someone using a screen reader or switch device may simply take longer to navigate through content, and time limits that work fine for mouse users can be a significant barrier. Third is avoiding seizure and physical reaction triggers. Content that flashes or strobes rapidly can trigger seizures in users with photosensitive epilepsy. WCAG's rule is that nothing on a page should flash more than 3 times per second. This might seem like an edge case, but the consequences of getting it wrong are really serious. Fourth is making your interface navigable. Users need to be able to move through your page efficiently and find what they're looking for. This covers things like having descriptive page titles, using link text that makes sense out of context, so instead of click here, you say what the link actually goes to, and ensuring a logical tab order when moving through interactive elements. It also covers skip navigation links, which let keyboard users jump past repeated navigation and go straight to the main content. Finally, input modalities. Not everyone interacts with a screen the same way, so functionality shouldn't rely solely on complex gestures or precise pointer movements. Think about a map with pinch to zoom. That gesture might not be available to all users, so you'd want to be able to provide buttons to zoom in and out. More broadly, touch targets should be large enough to be easily activated, and functionality should work across a variety of input methods. The third principle is understandable. This means that not only does content need to be perceivable and the interface operable, it also needs to be clear and predictable. Even if a user can technically access your content, if the interface behaves unexpectedly or the content's confusing, the experience breaks down. WCAG defines 3 areas here. The first area is readability. Text content needs to be readable and understandable, and the one concrete example of this is identifying the language of your page in HTML using the lang attribute. This might seem like a small detail, but it matters a lot for screen readers. A screen reader needs to know what language a page is in so that it can pronounce words correctly. If your page has sections in a different language from the rest, they should be marked with a lang attribute on the relevant element as well. The second is predictability. Pages should behave in expected ways. Your navigation should look consistent across pages, and things shouldn't change unexpectedly without the user initiating it. For example, changing the page or submitting a form when a user selects a drop-down item without pressing a button can be very disorienting, especially for screen reader users. The third area is input assistance. When a user fills out forms, errors should be described clearly and helpfully. Instead of a generic pop-up that just says error, tell the user specifically what went wrong and how to fix it. So instead of just flagging a postal code field as saying invalid, say something like, please enter your postal code in the format A1A1A1. The more specific and actionable the feedback, the better. And honestly, this is just good UX practice for everyone, not just for users with disabilities. The fourth and final principle is robust. This one's aimed squarely at developers. It means your web content should be built using correct, current code that can be reliably interpreted by browsers and assistive technologies. The core idea is to use the right tool for the job. HTML has a rich set of semantic elements that carry meaning about the role they play in a document or interface. When you use semantic elements correctly, browsers and assistive technologies can interpret your interface accurately and respond to it the way that users expect. Here's a classic example. You can make something look and behave like a button using a div element with some CSS and a JavaScript click handler. It might look identical to a real button on screen, but a screen reader looking at a div has no idea that the element is interactive. It won't announce it as a button, and it won't be focusable by the keyboard by default. And a user navigating without a mouse might never find it. If you use an actual button element, all of that comes for free. The browser already knows it's a button, screen readers know how to handle it, and the keyboard navigation just works. So the principle is, whenever a native HTML element exists for what you're trying to build, use it. This applies to buttons, headings, links, fields, forms, navigation regions, and more. If you're ever unsure whether a specific element exists for what you're building, the MDN Web Docs is an excellent resource. Their accessibility documentation in particular is very thorough. You can find that and all the other links that I mentioned on the resource page. Before we move on from the technical side of WCAG, there's one more tool worth knowing about, ARIA, which stands for Accessible Rich Internet Applications. To understand why ARIA exists, let's look at a concrete example. Here, we have a progress bar built using a plain div. To a sighted user, it looks completely fine. There's a bar and it shows 75%. The visual is clear. But look at what a screen reader gets from this, just 75%. No context. It's just a percentage. If so, of what? A label, a score? The screen reader has no idea that it's looking at a progress bar because a div carries no semantic meaning on its own. It's just a box. This is where ARIA comes in. By adding role equals progress bar and the ARIA value attributes to the same div, we've given the screen reader everything it needs. Now instead of just saying 75%, it announces progress bar, 75%, minimum 0, maximum 100. Same visual, but a completely different experience for a screen reader user. There's a well-known principle called the first rule of ARIA. If a native HTML element already exists with the semantics you need, use that instead. A native button, a native input, or a native nav all come with built-in accessibility information for free. ARIA is for situations like this one, where no native element exists for what you're building. It's also worth knowing that bad ARIA is worse than no ARIA. Applied incorrectly, ARIA attributes can actively mislead assistive technologies and make an interface harder to use than if nothing had been added at all. So use native HTML first and reach for ARIA carefully and deliberately when you actually need it. I'll link the MDN documentation on the resource website if you want to go deeper. Okay, so we've covered WCAG in detail. Now let's look at what EN 301549 adds beyond that. WCAG is focused specifically on web content, while EN 301549 takes a much broader view. It defines accessibility requirements for all kinds of software and technology, including operating systems, native desktop applications, and mobile applications, as well as software running on closed systems like kiosks or ATMs, and authoring tools. That last category, authoring tools, is an interesting one. Authoring tools are applications used to create content. Think of things like VS Code, Microsoft Word, or Adobe products. EN 301549 addresses not just whether these tools are accessible to use, but whether the content they generate is accessible. The idea is that if you're building a tool and other people use that tool to create content, your tool should make it easy, or ideally be the default, to produce accessible output. The specifics of this are defined in a separate standard called ATAG 2.0, which is the Authoring Tools Accessibility Guidelines, and we're not going to go deep into ATAG in this video, but if you're ever building something that would be considered an authoring tool, that's the standard you should be looking at. The other major thing EN 301549 adds is a detailed framework for how software systems should interact with assistive technology. It defines how an accessibility API needs to expose information, things like the role of an interface element, its current state, and its name and description, so that assistive technologies like screen readers and braille displays can read and interact with the interface. It also defines obligations for the assistive technology side, covering how AT needs to interact with the APIs that systems expose. This bidirectional definition is what makes the whole ecosystem work. Without it, there'd be no guarantee that a screen reader built by one company could interact with an operating system built by a different company. Let's talk about some practical tools that can help you check whether what you're building is actually accessible. The first is a contrast checker. These tools let you input two colors, a foreground and a background, and check whether the contrast ratio between them meets WCAG requirements. The standard sets minimum contrast ratios for text with higher requirements for smaller text. The one I'd recommend starting with is WebAIM's Contrast Checker, which is also linked on the resource page. It's free, straightforward to use, and tells you exactly which WCAG conformance level your contrast ratio passes or fails. Many design tools like Figma also have contrast checking built in, but the WebAIM tool is a reliable fallback for checking any combination of colors. The second type of tool is a color filter or a color blindness simulator. These let you view your interface as it would appear to someone with a color vision deficiency. There are different types of color blindness, and a good simulator will let you check several of them. This is useful for catching situations where you're accidentally relying on color alone to convey information, which the distinguishable criteria under perceivable in WCAG flags specifically as a problem. The third, and probably most powerful tool for a developer, is an automated accessibility checking tool. Google Lighthouse is a great example of this. It's built right into Chrome's developer tools, and it can audit a live web page for a range of accessibility issues, give you a score, and provide specific recommendations. It's not a complete solution, since automated tools can only catch a subset of accessibility issues, and there are things that require human judgment, but it's still an excellent starting point and a great way to catch obvious issues quickly. We're going to take a look at Google Lighthouse in action. Alright, so I've spun up a simple web page for this demo. Let me walk you through how we use Lighthouse to audit it. So first, we're going to open Google Developer Tools. So we'll do that by going Chrome, View, Developer, and then Developer Tools. In here, we can open Lighthouse. From this, we can choose which things to check for. We're just going to check for accessibility. So then you go Analyze Page Load. It's going to run the audit, and then it will give us a report. So we can see on this page, we're getting an accessibility score of 65, which is not very good. So we can scroll down and see what some of these issues are. Lighthouse will lay out for us what's actually going on so that we have the knowledge that we need to fix them. So we can see things like our contrast is off, we're missing a Lang attribute, or the document doesn't have a main landmark. It also will show us the things that we've passed, and then it gives you a list of things that aren't applicable. So these are things that you don't use, but the Google Lighthouse is able to check for. A few things to keep in mind as you look at the results. Lighthouse gives you a score out of 100, but the score is not the whole story. It is just testing for things that it can automatically detect, like a missing alt file text, a missing alt text on an image, color contrast, or missing form labels. There are other accessibility categories that the automated tools can't even check. Things like whether content's structured logically, or if the error messages are actually helpful, or whether the overall experience makes sense for someone using a screen reader. That's why automated testing is a starting point and not a finish line. Alright, tools are helpful, but let's talk about what best practice actually looks like when it comes to building accessible software. The gold standard, and this is widely agreed upon in the accessibility community, is to involve users who have accessibility needs directly in your development process. This means more than just testing with them at the end. Ideally, you're including these users during requirements gathering and specifications, so that accessibility needs are informing design decisions from the very beginning rather than being retrofitted later. The reason lived experience matters so much here is that it's difficult for a developer to anticipate every way that a user might interact with a system. A tester who uses a screen reader every day will notice things that a developer who's never used one simply misses. They'll notice when a focus order is confusing, when an error message is unhelpful in a specific way, or when a feature works technically but is still frustrating to use in practice. That kind of feedback is invaluable and really hard to replicate through developer testing alone. If you don't have access to testers who use assistive technology or adaptive hardware, and often in academic or small team contexts you won't, a structured alternative is to conduct a cognitive walkthrough using user personas. This is a technique covered in CSCI 310, Human-Computer Interaction. You create detailed personas representing users with different accessibility needs and walk through your software's key tasks from their perspective, asking at each step whether this persona would be able to complete this task and what barriers they might encounter. It's not as effective as real user testing, but it is a structured and methodical way to catch issues you might otherwise miss. Alright, let's wrap up with some key takeaways. Accessibility is about ensuring your software is equally available to users with disabilities or other barriers to use. It needs to be built in from the start, not just added at the end. The two main standards are WCAG and EN 301-549v3. WCAG is your primary reference for web development, organized around the four POUR principles: perceivable, operable, understandable, and robust. EN 301-549 incorporates WCAG and extends it to cover native applications, operating systems, kiosks, and authoring tools, and defines how systems must interact with assistive technology. In Canada, EN 301-549v3 has been legislated federally through the Accessible Canada Act. Practical tools like contrast checking, color filters, and Google Lighthouse can help you catch issues, but they're not a substitute for thoughtful, inclusive development practices. When native HTML elements aren't enough, ARIA provides a way to give assistive technologies the information they need, though it should always be a last resort after native semantics. The gold standard is involving users with accessibility needs directly in your process from the beginning. Yes, accessibility adds development cost, but building it from the start costs significantly less than retrofitting it later. It widens your potential user base, and it gets easier the more you do. It's one of those areas where doing the right thing and doing the practical thing happen to point in the same direction. For all the links I mentioned and more, check out the resource website. I've included the WCAG Quick Reference Guide, the MDN Accessibility Docs, and several other tools and references there. The link is on the screen right now. Finally, thank you so much for watching.